Hi there, and welcome to my channel. In this question, we are given that the temperature of coffee in a cup at time t minutes is modeled by a decreasing differentiable function c, such that c of t is measured in degrees Celsius. And for values t between 0 and 12, selected values c of t are given in the table above, this table here. And the question is, we need to approximate C prime at time 5 minutes using the average rate of change of C over the interval from 3 to 7. And we need to show the work. And so let's start by recalling what is the average rate of changes. Average rate of change. This is equal to f of b minus f of a divided by b minus a. And so graphically, if this is our function, this is point A, this is point B, this is function going somehow like this is f of A, f of B, then the average rate of change is given by the slope of the line which connects the endpoints, f of A and f of B. And so let's use our specific numbers here. And so this is equal to C of 7 minus C of 3 divided by 7 minus 3. And looking at the chart above, we see that C of 7 is 69 and C of 3 is 85 degrees. So getting back here, this is 69 minus 85 divided by 7 minus 3, which is negative 16 over 4, which is negative 4. And the units are Celsius per minute. In this question, we need to use left-Riemann sum with the 3 subintervals that we have here, these 3 subintervals, indicated by the data in the table to approximate the value of the integral from 0 to 12, c of t dt. And then we need to interpret the meaning of result 1 over 12 of this integral in the context of the problem. And so let's see what the left-Riemann sum is. And for that, let's draw the picture here, which is we have points 0, 3 minutes, 7 minutes, and 12 minutes. And then the values are 100. And here's the value is 85. Here the value is 69. And then here is the value of 55 degrees Celsius. And so the left-Riemann sum means that we approximate the areas of these rectangles here, with the product of base times the value on the left side of this rectangle. So we really approximate it with the area of those rectangles. And then for this rectangle, we approximated base times the left side, which is 85. And then for the last one, we approximated with base times height, which is 69. So the integral from 0 to 12 c of t dt is approximately equal to, and this is equal to 100 times base, which is 3 minus 0, plus 85 times 7 minus 3, plus 69 times 12 minus 7, which is equal to 100 times 3 is 300, 85 times 4 is 340, and then 69 times 5 is 345. So this is equal to 985. And so we need to approximate or to interpret the meaning of the result, which is 1 over 12 over this this integral over 12 c of t dt. And the interpretation is that this is an average temperature for time t between 0 and 12 minutes. Because the integral, this is the definition of the average value over this interval. In this part of the question, we are given that for the time between 12 and 20 minutes, the rate of change of the temperature of the coffee is modeled by the function, the derivative c prime of t, which is equal to negative 24.55 times e to the power 0.01 t over t, where this derivative is measured in degrees Celsius per minute. And we need to find the temperature of the coffee at time t equals 20, and shows the setup of our calculations. So to answer this question, we need to recall the fundamental theorem of calculus, which states that f of b minus f of a is equal to integral from a to b f prime of x dx. And in our case, c of 20 minus c of 12 equals the integral from 12 to 20 of negative 24.55 e 0.01 t over t dt. And we just, to calculate c of 20, we need to calculate this integral, and then c of 20 will be equal to 55 plus this integral. And so let's pull out our calculators and calculate that. So let's calculate this integral. And so this is, let's go to mathematics, integral. And this is integral from 12 to 20 of the function of negative 24.55 times e to the power 0.1 x, doesn't matter whether we use x or t, divided by x, and this is with respect to x. And then we also need to add value c of 12, which is 55. So enter. The answer is 40.329 degrees Celsius. 40.329 Celsius. And so as we just calculated, c of 20 is 40.329 degrees Celsius. In this part of the question, we are being asked to determine whether the temperature of the coffee is changing at a decreasing or an increasing rate for the time between 12 and 20 minutes. And note that we are given the second derivative here. And how do we determine that? So first of all, note a couple of things here. C prime of t is less than 0 for t between 12 and 20 minutes, right? Because negative 24.55 is negative here, and then exponent is always positive and t is positive. So overall it's negative times positive divided by positive is negative. However, for the second derivative c prime of t is positive. Again, for the same reason, if you take a look here, 24.55 is positive, exponent is positive, and then 100 minus t is positive because t is less than or equal to 20, and then t squared is positive. So overall, c double prime of t is positive. And now carefully, if you carefully read the question, it says not whether the first derivative is increasing or decreasing, but the question is whether the temperature of the coffee is changing at a decreasing or increasing rate. So really what's happening, this is the question, how changes c prime of t, absolute value of c prime of t. And we can see that c prime of t, absolute value is actually decreasing, because it goes from more negative to less negative as time goes by. So the answer here is that the temperature of the coffee is changing at a decreasing rate. Thank you for watching. If you liked this video, please don't forget to click the like button, leave your comment in the section below, and subscribe to my channel, where you can find more solutions to the AP Calculus AB and AP Calculus BC problems. And I will see you in the next video.